welcome. For those of you who don't know me, my name is Jared Davis. I'm the CEO of Nbryo, and thank you very much for coming along to our little seminar this afternoon. I'd like to start by first of all thanking the Wagyu Association for enabling us to put on our seminar here today, and supporting us both at the Wagyu Edge conference and here at Beef as well. What we're going to do is run through a series of short presentations, a couple from key members of our team, and then a talk from Professor Ben Hayes from the University of Queensland. And what we're planning to do is to try and give you a bit of information about Nbryo as a business, where it's come from, what we're planning to do, and the sort of impact we hope to have. So without further ado, I'll start with our first speaker, who's our Director of Technical Development, Nick Cameron. Many of you may know him. He's been involved in the Australian breeding industry for a long time as the manager at Nbryo, but his was the original concept around Nbryo, and he's going to talk to you about that and how it evolved out of Nbryo. Nick?
Thank you, Jared, and welcome to everybody here today. Nice to see some familiar faces and some not so familiar, but good to see everybody. I'd like to start with a little bit of a story. I've just come back from a trip overseas and visited a semen company overseas, and they use genomics very, very heavily. It's mainly in the dairy industry, but they started with genomics 8 years ago, and we're using about 5% of the semen they were selling was based on a genomic profile. Now it's 85%. So farmers do not look at anything else in the dairy industry other than the genomic profile of an animal, which I found quite extraordinary. So that's a little bit of a story, but I'd like to start with the conception idea. So this is where Nbryo has been conceived. So as you can see, there's two meanings for conception. One's something conceived, notion, idea, design or plan, and the other one, funnily enough, is the fertilisation of an ovum by a sperm. So Nbryo, which is where I worked in the past. I've been a farmer all my life. So it's owned by Ewan and Kay Murdoch. Ewan is the other co-founder of Nbryo. He's played an integral part in the development of Nbryo. So we started back in 2006, contract breeding, and that was mainly with AACO. Then we moved on to Georgina Pastoral Company with Ultra Blacks, so it was the birth of Ultra Blacks in Australia. And we also Nbryo is currently working with CPC as well. During that time, we did a lot of embryo transfer. This is sort of the background on the development of what was performed at Nbryo. So as you can see, we were running pretty extensive programs, all based around artificial reproduction, and that has led to the thinking behind Nbryo. So being able to visit these large organisations and look at the impact of embryo transfer in a production sense has been one of the unique things, I think. Being able to see the whole supply chain and the impact that embryo production can do on that supply chain is pretty unique. During that time, we also created our own in-house genomic platform. The whole purpose behind that genomic platform was to eventually start identifying embryos at the genomic stage and at the 4 to 7 day stage. And once you start identifying embryos at that stage, it becomes pretty powerful in a production system, and all sorts of sustainability and production increases can be gained by focusing on something that enters the production system, or way before it enters the production system. You've got an idea and a handle on what's going to go into that production system. So that's sort of unique now. So embryos are the start of livestock production. So, and I think if everybody could just think about that for a minute, but that's where the livestock production system starts. So it starts on conception, and once you've got conception, that's basically set. All your genetics are set then, so that becomes a powerful time frame that you can look at identifying embryos that you want to go into a production system. So once you identify those traits, then that's applying a lot of cost and a lot of technology at that stage. So you need to look at ways to then reduce the cost. And reducing the cost in this type of procedure is done through multiplication. So any multiplication of an embryo is a division in cost. So you can actually multiply, and Nbryo has patented technology around this, which is one of the things that sets us apart, I suppose. And we're looking at this as a total breeding platform. It's not a specific area in the platform. It's an all-encompassing platform, which is, I think, very, very exciting. So we start at identifying the right donors and sires, helping the client identify the right donors and sires that go into their system. We're developing digital twins that will exemplify those genetics and look at how those genetics will affect that production system going out to about a decade, and what sort of gains could be made during that time period. So you've identified them, you bring them into the system, you start creating embryos. Then you scrutinise those embryos and look for depending on the selection pressure that you want to apply at that stage, but you start applying selection then, and then multiply up the ones that have been selected out. So that all of a sudden becomes your first draft of cattle. And that doesn't take place in the yards, that takes place in the lab. And that has a tremendous bearing on genetic increase, a huge bearing. On top of that, that area, that time frame of conception through to a 7-day-old embryo, is a time frame that you can apply technology. And this is more technology that's being developed around the world. So there's all sorts of things which we're so fortunate to have Professor Ben Hayes here today. I've worked with Ben for a fair while now, about 10 years. He actually helped or did the genomic equations for Nbryo, so Ben and I have had a long association. But that is where technology and new technologies can be applied to improve, and I call it genetic enhancement. But that's where you can improve, again, the production system and the outcome of what goes into a production system. So this is part of the solution. So this is the Nbryo solution, the platform. And briefly, Sophia's going to go through this in a little bit more detail, so I'll gloss over some of this pretty quickly. But you start with a livestock production system, as I mentioned before. Well, sorry, I haven't mentioned the product profile. So you've got to develop a product profile. The product profile is similar to a breeding objective that you would have these days. So a breeding objective is just that. It's an objective, and it's something that you want to see happen 5 or 10 years out in your herd. A product profile is what do you want in the next generation. So you can become very, very specific with that. You can change things like what sex ratio do you want in your herd. You can change things like you can have breeds of different descriptions. You can have the female side, for instance, being highly adapted composite breeds that are highly fertile, and that might only make up 25% of your breeding profile. You might have 75% of very high value male beef, similar to a Wagyu, a full blood Wagyu, but whatever suits that production system. Every production system's different. Whatever suits that production system. And then you also might have backup bulls going in as well, and those backup bulls could be another breed totally, like a Hereford, for instance, that makes it easy to identify animals that haven't been bred through the embryo system. So that sort of gives you an idea of what a product profile is. Like I mentioned before, identify the dams and sires, create the embryos. We genotype the embryos. We started genotyping embryos in 2012. So genotyping embryos is nothing new. It's standard practice in human IVF. They genotype embryos on a routine basis. After that, you select the embryos you want to go forward with, and that depends on the selection pressure that you want to put on those embryos. And then that becomes a multiplication of those ones that have been selected out. We've got preservation in there as well, and then implant, which is another key component of the embryo platform. So these are devices we're developing that will enable the transfer process to take place by a semi-skilled operator. All that's recorded, continuous improvement, and the loop starts again. So I'd like to see embryos at some stage as the preferred method for breeding. I think embryos will become that. I think we'll eventually be pushed that way, just with the amount of pressure that's coming on livestock production globally. Like I mentioned, I've been overseas, and Europe's got all sorts of issues over there, but there's also issues in India, for instance, that we spend a bit of time in India as well. It makes our problems look insignificant when you go there. And the government over there is encouraging embryo transfer at a large scale. They've built 35 IVF labs, state-of-the-art labs that they're looking to try and solve some of their problems with. So embryos just need a reduction in costs, and also they need to be accessible to producers, not the top tier, but the commercial producers, and the practicalities need to be sorted out. So this is, like we've only sort of come out of stealth mode, we call it, just recently, but it has been going on for quite some time. So there has been a lot of money spent in the founder investment. That's all the work done at Nbryo, and that's been pivotal to the creation of Nbryo. Thank you. And there's also been equity funding from leading companies and individuals, but I'd really like to highlight and acknowledge the Bill and Melinda Gates Foundation and MLA for their contribution to the research for embryo. It's been absolutely fantastic. So this is our team. It's amazing that we've been able to get a group of people together of this quality. It's pretty. I'm very, very proud of the team that we've got. So we start with Ewan, who's currently the chair, and Tim Samway. All these people bring a variety of skills to embryo, and we're very lucky to have them being the stewardship of the embryo business. And also, I'd like to acknowledge Holly Kramer, who's here today as well. So thanks for coming, Holly. We also have a great executive and lots of skills, very, very good skills in that executive team that are quite rounded and cover embryo as a platform. that's probably the thing I wanted to highlight, was that we're not just focused in a specific area. We've got a whole wealth of talent around all sorts of different areas in a breeding business, and certainly in this business. So a question I wanted to pose certainly to the producers here, but it's also with people in the supply chain as well. I'd like you to explore the possibilities in your system. So if you can just think about how an embryo system might change your business and what that might look like. It's not as easy as you might think. It does require a little bit of planning and a little bit of thought. I've mentioned this to quite a few people in the past, and it's interesting, some of their responses. I was talking to one guy, for instance, who thought he needed to increase his Wagyu female population, for instance. That increase in a Wagyu female, and I asked him why, and he said, well, that's to produce more Wagyu steers. I said, well, you've got an excellent adapted female herd out there. Why don't you just produce the steers and totally leapfrog that? And yeah, the penny dropped, and anyway, that sort of raised his eyebrows, I can tell you. But yeah, that's what I'd like to leave you with, is just explore the possibilities in your system and see where you think the embryo technology might fit. Thank you.